this question, we are told that the figure 1 shows a burette partly filled with a liquid. The burette was initially full to the 0 mark. If the quantity of the liquid removed has a mass of 22 grams, determine the density of the liquid. Let's start this question by looking at how the burette works. The figure shows a burette full of a liquid. Unlike a measuring cylinder, which will show a value greater than 0 when it is full of the liquid, in a burette, when the burette is full, then the lowest point of the meniscus is against the 0 mark. Now, the burette is a thin tube, so the meniscus is usually highly curved. The tap is usually somewhere down here. So if the tap is opened, drops of water will fall off from this other end, as we have just seen, and the level of the water or the liquid in the burette drops. Let's replay the simulation once again. Notice what happens to the drops at this end and the level of the liquid in the burette when we open the tap down here. So I open the tap. Drops of water fall off from this lower end of the burette, and the level of the water drops. You may have seen this in the chemistry lab. Now let's go back to the diagram. As usual, we want to start by looking at the scale of the burette. This is 0 centimeter cubed mark, and then this is the 10 centimeter cubed mark, while this is 20 centimeter cubed mark. Between 0 and the 10 centimeter cubed mark, there are 10 large divisions. For example, if we count from here, we'll see that if this is 0, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 large divisions. And because this number here is 0 and this one is 10, then one large division will represent 1 centimeters cubed. One large division here is divided into 2. So the smallest division on this scale represents 0.5 centimeters cubed. So the smallest division on the scale represents 0.5 centimeters cubed. Let us read this volume here. This is 10, and that means that this is 11, and the lowest point of the meniscus is between 11 and 12. Therefore, the volume of the water that we have just run out is 11.5 centimeters cubed. 11.5 centimeters cubed. The mass of the water that we have just run out, we've been told it's 22 grams. Therefore, the density of the liquid is mass of the liquid divided by its volume, and this is 22 grams divided by 11.5 centimeters cubed, and this of course gives us 1.91 grams per centimeters cubed, and that is the density of the liquid.